All right, well, welcome back. We're getting into the meat of the chapter 21 there, where we're talking about what else we can do with carbonyls. And last time we had talked about if we put a ketone or an aldehyde under acidic or basic conditions, we can generate this enolate, which gives us some additional chemistry that can happen at the alpha position to the carbonyls. And so we're going to just continue that idea here, right? And so here we have imagine a beaker where we have some ethanal, right? Ethane aldehyde, ethanal. And it's an aqueous solution of sodium hydroxide. We're just mixing this around, okay? If we do this, right? Let me zoom in here. If we do this, then, you know, the first thing you guys should see as well, right? We're going to end up generating the enolate here, okay? And hopefully you guys know that when I draw this, right, we also have the resonance structure that's there with the negative on the oxygen and the alkene and all that, right? But this is kind of the thing that's going to do something for us, right? So we're just kind of shorthanding this, and I'm perfectly fine with you guys drawing that also, as long as you understand why we can do this to begin with, right? Because this seems dumb, right? This seems like, oh, hydroxide's not a strong enough base to deprotonate an alkyl hydrogen, and it isn't, but that's not just any normal alkyl hydrogen, right? And remember, this is also an equilibrium too, right? It's a little bit of a different thing here, right? But so now we've got an enolate, and what's going to happen is this enolate is going to find a friend, right? And its friend is, let me draw that a little bit nicer, another aldehyde. So remember, we're doing this all in solution, right? On paper, we just have one of these react with one of these and one of these. But, you know, off screen, right, so to speak, what we don't always show with these mechanisms and everything is that, you know, these are all in solution. There's multiple hydroxides and aldehydes, all this stuff kind of swimming around, right? And so this is going to encounter that, and we can actually see a reaction happen, right? And so the negative is going to attack, well, I meant to do that in red, so let's try that again. The negative is going to attack the carbonyl, right? And we're going to swing open the door. An enolate is a okay nucleophile, right? It's got a negative charge, it's kind of soft, you know? So it's going to do that. And what we end up with is, let me draw this in a manner that doesn't look too odd, but does get the point across. All right, we're going to end up with this. And then let's end up putting a hydrogen on there. Let's pick up a hydrogen from water. All right, and at the end of the day, let's draw it a little bit differently, just to kind of make it look nice. There is that, okay? So that hydrogen didn't disappear, right? It's just, I just made it understood, right? So this is what we would call an aldol addition, right? An aldol addition. Aldol additions work pretty well for aldehydes. It's tough to isolate these with ketones, though. With aldehydes, right, with ketones, okay. But in reality, just kind of speaking off the cuff, I guess, or speaking from observation of years of doing this, we don't really do too much with the aldol additions. We do more with the next step, which would be the aldol condensation, okay? And so again, we go back to this idea of what is off screen, what is off the stage. Well, we made our product, and oftentimes like, woof, man, I finally got that product, and that's it, and you know, we just go on with our lives. But this is still floating around in solution. And so now if we take the solution and we start to heat it up, right? Generally speaking, heat it up. Here's what's going to happen. So I'm going to take this guy. Right, and let's take the exact same thing, but let's start to heat it up. This hydrogen down here, right? This hydrogen down here is still alpha to that carbonyl, right? And now it's also now it's feeling a little bit more acidic because this alcohol over here might be pulling away electron density, all this kind of stuff too. The point being, this is a more acidic hydrogen here. okay? So what's going to happen is more base, right? And so if we heat this up, this is usually where we end up. So let's do this, double bond to green here, okay? And so we would call this an alpha beta unsaturated carbonyl here, okay? And these are really useful. We can start to do some very good chemistry at what we would call the 4 position, right? So the 1, 2, 3, 4 position right there. So we'll learn in probably the next video what's known as a Michael addition, right? So we can do a lot of chemistry at that 4 position. And then we'll have to learn about the 1, 2 versus the 1, 4 additions, which we mentioned way, way, way back, almost like 2 weeks ago, right? Can you imagine? Okay. But anyway, so this would be our aldol condensation product here, okay? So once we start to warm this up, notice we will make water as this happens, and then we want to heat this up to kind of drive off the water, right? And we end up kicking off hydroxide, which is not that good a leaving group, which maybe kind of helps explain why we have to heat this up a little bit. Now, we're under basic conditions, right? So kicking off another hydroxide, it's not a great leaving group, but, it's reasonable under these conditions, right? Now, ketones will go all the way to the aldol condensation product there, right? So we can push a ketone all the way to the end there, but it's hard for the ketones to stop here, right? They'll usually reverse back, is what it is. But there it is, right? So this is the major idea that we have, right? But maybe you guys start to see, or actually, no, I forgot. I want to show you the shortcut here first, right? Shortcuts are good. So let's go back to this idea here. So remember what we did at the end of the day is we mixed this. I'm just trying to get my colors right here because actually this is the 3rd time I've had to record this video and I keep changing colors on myself because I'm a dum-dum. So let me try and get this all good. All right. And let's do this in black. And then we'll do this here. Okay. So at the start of this, right, we had a solution of our aldehydes together. And we put in some hydroxide and we start to warm this up. And what we end up doing is this, right? We end up taking those 2 hydrogens and that oxygen right there. So we kind of snip these and we squish these together. So if you guys remember me talking about ozonolysis a while ago, we talked about the snip, slide, and slap. I kind of call this one the snip and squish, right? So what we end up doing is snipping off water and squishing these 2 things together here, right? So when we're doing an aldol condensation, right? We end up squishing these 2 together, right? Let's do that in red, right? There's this, and what we end up leaving behind is, right, we have that hydrogen in green, right? And we still have that hydrogen in black down here, okay? And this is kind of your shortcut. What we end up doing is replacing one of our carbonyl oxygens. We end up adding it to the alpha position of the other carbonyl, right? That's all it is. So it's similar to the Wittig reaction that we saw also, wherein we replaced the carbonyl oxygen with the Wittig salt there that we had, the phosphonium salt that we ended up making, right? So we just kind of snip and squish these 2 together, right? And so we end up with a double bond here, right? And we'll have the carbons that we had from the chain here also, right? So hopefully that kind of makes sense, right? We basically remove water, squish the 2 together, okay? Another problem or something we have to consider is what do we do if we want to make an asymmetric condensation, right? So let's say I have these 2 here, right? And I mix them together. I heat them up. I want to drive off water, whatever you want to do here, right? There's going to be a problem. Do you guys see what the problem is? I want to mix this and this to make a specific product, right? But this can react with itself, this can react with itself, this can react with that can react with this, and we end up with different products in just one giant mess. So when we do something like this, we want to tweak our conditions a little bit, okay? So here is what we would do instead. Let's say for argument's sake, right, we want to make a specific product. So what we would do is first come in and treat this with LDA, okay? And what this does, right, we just mix this in LDA, and that's, all we're gonna do in that case is just generate the enolate and just have that thing stir around in solution, okay? So we mix those two together, we let it stir around, then we come in and we would add the other component to this, okay? So we mix this around first, we come back with this, right? And then we can usually heat this up, is what it is, right? Heat this up or drive off water or whatever it might be in this case, right? And if we do that, I'm trying to get you guys a page number here for you guys to pick up on this. There it is, right? So I'm looking at page 974 and 975, right? So that's where I'm kind of pulling this from. So LDA plus this right here, right? And then we usually finish up with a water workup, or we heat it up, or whatever it might be, right? And then what we will end up doing is this, right? There, right? So we end up controlling our reaction one bit at a time is what it is, okay? And so you guys can add some heat there to the second stuff. It's a little bit, I think, let me do a little bit of ideas here, a little bit of thoughts. The book I think the book kind of tries to paint almost too broad a picture with what's going on with these reactions. They're like, well, you have to do these conditions unless this won't work and this and there. And I'm not saying it's wrong, I'm just saying, hey, we're just learning this, right? Let's understand the basics and then we can come back and tweak this if we need to get into the lab, right? So I'm not trying to hedge or fudge numbers here or anything like this. I'm just saying, here's the basics of what we want to do, right? If we want to do one of these crossed condensations, right? Generate the enolate first, then add your second part in there and get your product. Wow, this isn't acidic enough. Okay, whatever, right? We're doing chemistry on paper. We can take a little bit of a shortcut here, is all I'm saying, okay? But the point being, don't just mix these two together, right? Don't just mix these two together and expect that this is the product that's going to get formed. We got to tweak our setup here a little bit, okay? That's the point that I want to make with you guys. All right. So I think that's a good stopping point for this, because the next thing we get into are Claisen condensations, which are related, but we want to come and talk a little bit more about those separately. Okay? So another somewhat short video for you guys. Fantastic. I'll see you guys next time.